Are we surely ready? We've come a long way, my dear friends. We've gathered a rich data set, our inner world, and a clear sense of what's out there. We might think we're ready to meet the love we desire. But what if we've done the shadow work, we've reached healthy self-love, yet we still can't spot emotional unavailability or the low potential for a lasting relationship? In machine learning, that's class imbalance. When one class outweighs the other, the model struggles to perform well on the minority class. Why does this matter in love? Because low self-esteem can make us feel unworthy. A lack of identity can push us into relationships to fill a void that should be occupied by self-awareness and purpose. Childhood exposure to dysfunction may make us confuse intensity with passion. As Bell Hooks said, we're often drawn to what's familiar, not what's healthy. And as Gabor Mate warns, those early patterns get wired into our nervous system. When we lack purpose, the relationship becomes our identity. This leads to self-abandonment and codependency. A Harville Hendricks notes, we might expect partners to soothe old wounds instead of healing them ourselves. Without a secure attachment style, we gravitate towards our opposites, the anxious drawn to the avoidant, replaying the story that love always leaves. So what can we do when classes are unbalanced? We can collect more data by spending more time with that person. Remember, in the first 3 months, we are not ourselves, but the ambassadors of our true selves. We can also change our metrics. What goals could actually align with our life and identity? Perhaps we want companionship, not marriage. As we learned in our previous videos, we must avoid creating models that are either overfitting or underfitting. Translated to our love patterns, an overfitting model resembles to operating from people-pleasing tendencies. An underfitting is too rigid, with no wisdom towards compromising. Class imbalance is resolved through resampling, which can be conducted through various methods. The issues to address are oversampling the minority class or undersampling the majority class. Random oversampling duplicates existing data points from minority class with replacement. However, if it increases more of the minority class than needed, oversampling may risk leading to overfitting or a model which is too adaptable. In relationships, this could lead to self-abandonment to over-accommodate the other. Random undersampling removes existing samples from the majority class. Risks associated to undersampling revolve around the loss of relevant data. SMOTE, synthetic minority oversampling technique, uses the k-nearest neighbors algorithm to generate synthetic example and oversample the minority class. TOMEC removes bridges, TOMEC links, between neighboring minority and majority class instances to handle data points which are close to one another, though belonging in different classes, just like cutting ties with situations too similar but in conflict. Addison addresses oversampling by targeting data points which were wrongly classified and generating samples next to them, just like giving attention where our instincts proved wrong before. What about evaluation metrics? In binary classification, we work with true positives, correctly spotting a good match, and false positives, thinking it's love when it's not. The ROC-AUC tells us how well we can rank a true match higher than a false one, vital when both classes matter equally. And remember, relationships evolve. New values or expectations can emerge at any time. In machine learning, we can also handle imbalance at the algorithm level. Let's think of when we release ourselves of peer pressure or the belief that relationships have to be full of drama and hard work. When working at an algorithm level, it's like just shedding a pre-programming and go for who truly sees us and can support our peace and growth. In a machine learning model, we use algorithm level when datasets are too limited or when we fear resampling might lead to information loss. Just like a scenario when we become overly enthusiastic about a person that we lose focus on our needs. What about that inconvenience, be it a red flag or a situation that goes nowhere? Call in anomaly. Detection resolves situations when the impact of an outlier is higher than that of other classes. The anomaly detection is therefore focused not on balancing classes, but on highlighting possible outliers that could affect performance. On an algorithm level, anomaly detection can be identified either through the one-class SVM, support vector machine, or focusing on how that aspect, such as disagreement on core values, will affect one's entire relationship. Isolation forest uses the decision tree logic to isolate anomalies till they become fewer and fewer. In relationship, think of the impact of communicating over an issue such as sealing a long-distance relationship. Local outlier factor, LOF, implies comparing the density of a cluster to that of its neighbors. Anomalies can be identified through a lower density than that of neighbors. In relationships, think of putting positive and negative aspects in balance. Autoencoders, which in unsupervised feature learning can reconstruct normal data. In relationships, think of a lucid, detached exercise meant to identify love bombing against what would be the healthy pace in which a relationship may evolve. K means clustering will help us go beyond the so good on paper trap and see whether whatever qualities we perceive in that person are sustainable on the long run. Could they be just a one-hit wonder? For example, is their success attributed to a crypto purchase at the right time without actually being accompanied by any activity which could reflect consistent stability and growth? We don't want an approach that is too cynical, so how do we follow our heart and also have your brain come along? Introducing cost-sensitive learning, through which data imbalance is addressed by assigning different costs to any misclassified class. Let's say we want to shine, while also looking for a life of the party type. Are we sure they would like to share the spotlight? To what point we would like someone who challenges us, and when criticism stops being constructive and turns our minimizing? We can introduce this approach either through cost matrices, built-in cost-sensitive parameters in some algorithms, or a customized loss function. Should we use cost-sensitive learning in any model? In machine learning, only apply it when misclassification produces disproportionate consequences. In life, always keep in mind the difference between compromise and sacrifice.